So we start. Okay, so very good day to everybody. This is data structures, and in today's class we discuss about the algorithm of data structures. What is the actual stepwise refinement technique? Okay, and then we discuss about the modular programming. Okay, so this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, once again, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. Right. So in this class, we'll have an intro towards stepwise refinement techniques. What is the actual programming style that's going on, and what is the imperative programming style that we'll be discussing. Okay, what are the steps that is actually needed to develop a modular program? Then we discuss about top-down modular programming and bottom-up modular programming. I've already discussed about this in the last class. Okay. Then we discuss about structured programming. Then we go into OOP, object oriented programming. What is a pseudocode? Then we'll discuss some examples even, and what are the effective steps to the effective stepwise refinement technique. Okay. Then we discuss about refinement step, especially for the while loop or maybe do while loop. Okay. Then we declare and initialize the variables. Okay. So I've already given the independent work in the HEMIS. Please complete them. And I've already given you the deadline. Please submit them before the deadline, after which HEMIS will be closed. Okay. So at regular intervals, I'll be giving you some short videos to discuss the knowledge in our topics. Right. So maybe when you are going to write one algorithm, like any algorithm, so like if we have an appropriate mathematical model or maybe mathematical formula, we can come up with any algorithm. Okay. So the initial version will be containing like general statements or maybe some instructions that you are going to inform the audience what you should do. Step 1, step 2, step 3. Okay, this is the mathematical formula. For example, if you have to convert Celsius to Fahrenheit or maybe Fahrenheit to Celsius, okay, or maybe add two numbers, add three integers, so you can do. Okay, so we'll convert this informal algorithm, of course, into formal algorithm, which means that there are more definite instructions by applying any programming language syntax, maybe like Python or maybe C++ or maybe Java, whatever maybe, and you try to apply the semantics partially. Okay, only then people will try to understand. So finally, the program can be developed by converting this formal algorithm by the programming language manual. So you have to understand the logic of the program according to the syntax that you are trying to use. Okay. So there are several steps in order to reach a particular program from the definite mathematical model. Okay. So every step you need refinement. Every step you need conversion. Okay. So this is what you are going to convert an informal algorithm into a program. That's what you go with several stages of formalization, okay, until we arrive at the program. So this one you can call it as the stepwise refinement or maybe stepwise conversion technique. Okay. So there are three steps in the refinement process. Like we'll have the mathematical model with the informal algorithm that is converted into formal language with a pseudo language program that's actually imaginary. And from that you'll go with data structures with maybe C or maybe C++ program. Okay. So in the first stage, in the case of the modeling, we try to represent the problem, okay, using an appropriate mathematical model. For example, like a graph, binary search graph, or maybe binary search tree that will be explicitly representing. And at this stage, the solution of the problem is nothing but the algorithm which is expressed very informally enough. And after the next stage, the algorithm, you will write it in a pseudo language or maybe formal language. Okay, so that's nothing but a mixture of any programming language construct and lesser formal English statements as well. So you are going to perform these operations, okay, on several data types that actually becomes fixed enough. Okay, and finally we are going to choose an implementation for ADT, abstract data type, and you write the procedures, okay, for the various operations. So the remaining informal statements in the pseudo language algorithm can be replaced by a C code or maybe C++ code. Okay. So here you will have the different styles, okay, how you try to implement it. Okay, we will have procedural style, modular style, structured style, and object oriented style. So we have like different styles. So in the procedural style or maybe procedural programming, like it's nothing but the concept where you try to go for procedures. So procedure is nothing but a sub-program or maybe a routine or maybe a method, okay, that's actually a sequence of the commands that has to be executed. So any procedure can be called from any point within the same program, okay, that includes procedures or maybe itself, okay, so that's results in a recursion technique, okay. So procedural program with the case of large scale projects that you will be using, okay, so you can reuse the piece of the same code that is actually designed as procedures, and that's the way you define, okay, the logic of the program, okay, and it's very much easy to maintain the code as well, okay. The emphasis is all about, doing things. The emphasis is all about, doing writing the algorithms, okay, and most of the functions will be sharing like global data, okay, so the data move openly, around the system, maybe from function to function it will vary, okay, and functions also it will be transforming data from one form into another. So this is what it is followed in the programming step. Then you'll have imperative programming, okay, as you know, procedural programming, it's the sub part, a sub paradigm of imperative programming, because every step of the computation is described much more explicitly, clearly enough by using definite procedures, okay. So here you'll have main program and data. You'll go for procedure A, procedure B, maybe procedure X, maybe procedure B, maybe it is split into two parts, procedure Y and procedure Z. So this is how the splitting goes on, okay, in the imperative programming, okay. Then you'll go for modular programming, where you are going to subdivide the program into different partitions, what you call to be modules, okay. So you can write it much more easier, okay, the program in the modular form. So which means that the overall problem you are going to decompose it into, separate or maybe individual sub programs, okay. So a module, maybe it is decomposed into successive subordinate module, which means that a number of modules can be combined together to form a main module, okay. When it is decomposed small parts, even the small parts can be combined to make a main superior module, okay. So the sub module, the sub part, okay, it is located elsewhere in the program, and maybe superior module, okay, it is going to make a reference to a subordinate module, and it is going to run, it is going to call of its execution, okay. So the activity on the part of the superior module, you can call it as a calling, and this module you can call it as a calling module, and sub module is called as a called module, okay, right. So superior calling, subordinate calling, subordinate, it is a called module, okay. So the sub module can be sub programs, okay, called as the function or maybe called as the procedures, okay. So these are the steps that are needed to develop a modular program. You are going to define the problem and you are going to outline the steps that is necessary to achieve the objective or maybe goal, okay. And now you are going to decompose this problem into several subtasks. You are going to prototype a subprogram for each of the subtasks, and you are going to repeat these two steps, like decompose the problem into subtasks, prototype a subprogram for each subtask. So this one you are going to repeat it, okay, until further decomposition seems counterproductive, okay, right. So in the program, like main program plus data, it is divided into module 1 and module 2. Module 1 you have data plus data 1, so that's intact with the procedure 1, okay. Here we will have data plus data 2, that is intact with the procedure 2 and procedure 3. So these are the types of modular programming. Actually, like modular programming, you can call it as a procedural programming, okay. So it follows procedures. You are writing the code, okay, based on the function, and here the data is actually not active but passive in the modular programming, because in modular programming, like we decompose into subparts and we mainly enforce the procedures, not on the data, okay. So modular programming discourages the use of control variables and of course flags, okay, and their presence is going to indicate that the caller needs to know too much about how the function is actually implemented, okay. So there are two methods, one is top down and the other one is bottom up. So regardless of whether the approach is top down or maybe bottom up, okay, the end method is actually modular program, okay. So the end result is very important, because not all errors can be detected at the time of initial testing, okay. So it's still possible that there might be like errors, okay, or maybe bugs in the program, okay. So maybe if the error has been discovered, okay, and after maybe like program has been fully tested, like if you try to find the errors, which means that the modules concerned can be isolated and can be restored by them. So regardless of the method, if the program has been written in the modular form, you can detect the source of the error. That's the advantage. Okay, and you can test it in isolation. Okay, then if the program were written as a one function, because if it is written as a one function, you cannot actually isolate the errors. You cannot actually correct it. Okay, but this you can isolate it. You can test it again and again. Okay. So the advantage of the modular programming, you are going to reduce the complexity of the entire problem. You are going to avoid the duplication of code. So debugging program is much more easier and it's much more robust. It is more reliable. Okay, and it is going to improve the performance. Okay, so modular program, it is going to hide the use of data structure. Also, global data is hidden in the module. So still here also you can reuse the modules. Okay, so without need to rewrite or maybe retest. Also, modular programming improves the portability of the program, and of course it reduces the development work. Okay. Then you'll have top-down modular programming. As you know, top-down, like the rector contacting the students. Okay, so for example, the rector wants to tell some information to you, he cannot tell directly. He will tell it to the vice rector will tell to the dean will tell to the department head will tell to you. Okay, so this is how it goes. Okay, so the top down is nothing but the program. It's divided into like main module and maybe related modules, and each of the module again it will be divided into sub modules. Okay, according to the software engineering or maybe programming style. Okay, so division of these modules. Okay, the process will continue until the module consists of only of elementary processes. Okay, so that's actually understood, and still it cannot be further subdivided. So till then it will be dividing. So this is the top down algorithm design, like module 1, module 2, module 3, module 2, module 4, module 5, module 3, maybe module 6. Okay, so that's actually a technique you are going to organize and you are going to code the programs. Okay, where a hierarchy is being used, a hierarchy like topmost priority. Okay, so breaking the specification again into smaller and smaller pieces. Okay, each having a single entry and maybe single exit point. Okay, and here the control is actually passed downward through the structure. Okay, without unconditional branches to the higher levels of structures. Okay, so this one you can call it is a top down approach. Okay, then you'll have bottom up approach, again exactly the reverse. For example, if you have a complaint to the rector, so what you will do, you will not go straight and complain to the rector. You will tell to the department head, of course to the dean. Dean will go to vice rector. Vice rector will go to maybe some PA, personal assistant, again to the rector. So this is how the information passes on. Okay, so it's a style of programming where the application is actually constructed starting with the existing primitives of the programming language, and maybe constructing gradually. You'll have more and more complicated features at the top until all of the application has been written. Okay, so maybe like starting the design with specific modules and maybe building them into more complex structures. Finally it is going to end at the top. Okay, so the bottom of method you can widely use it in the testing. Okay, because each of the lowest level functions you are going to write and you are going to test. Only after that it will go to the next level. Okay, the testing you are going to do it by special functions, what you call it to be low level test functions, that you are going to have like different parameters, and maybe you are going to examine the results of the correctness. Okay, so that is what is going on in the bottom up approach. Okay, so once the lowest level functions has been written, it will be tested and maybe it will be verified to be correct. Okay, and the next level of functions can be tested. So since the lowest level functions already has been tested, okay, any detected errors are probably due to the higher level functions. You cannot say like only lower level functions have the problem. No, you are already writing, you are already testing. So problem with the higher layers. Okay, so the process will continue moving up the levels until the main function is actually tested. Okay, so this is the bottom up approach. Okay, from module 4, module 5, it will go to module 2. Module 6 will go to module 3. Module 2, module 3, it will go to module 1. Okay, so that is going on with the bottom up approach. Okay, then you have structured programming. That's actually a programming style with the several names. Okay, so you'll have like procedural decomposition, structured programming, and so on. Okay, so structured programming, definitely it's not programming with structures, but you are going to utilize the code structures in order to write the programs. Okay, so here you will have sequence of sequentially executed statements. Then you have a conditional if statement, looping or maybe iteration statement like for loop, do while loop you will have, and then structured subroutine calls or maybe the functions. Okay, so these are all present in the structured programming. So these are nothing but code structures, not just structures, code structures in order to write the programs. So in particular, the following language usage is forbidden. For example, like go-to statements are not allowed in structured programming. Break or maybe continue out of the middle of the loop is not allowed. Okay. And then multiple exit points to that particular function or maybe procedure or maybe subroutine not allowed. Like multiple return statements not allowed. Okay. So multiple entry points to that particular function or maybe procedure or maybe subroutine or maybe method not allowed. Okay. So in this style of programming, there's greater risk. Okay, so that's how the implementation details might be shared, across the functions. So that might be globally exposed. So that's the risk with the structured programming. Okay. So this in turn tempts other functions to use the implementation details. So everybody will be knowing. Okay, so that is the global risk. So there will be unwanted dependencies between different parts of the same program. So there are disadvantages as well. So decision made from the start of the project depend directly or maybe indirectly on the higher level specification of the application. Okay. So the specification also, it is not going to remain the same. It will be changing over time. So that is also a problem. Okay. So when this happens, there is greater risk that larger parts of the application needs to be rewritten. Okay. You have advantages as well. So clarity. Okay. So the structured programming has a clarity and of course logical pattern, okay, to their control structure, and due to this tremendous increase in the programming productivity. And another one is that every block of the code has a single entry point, of course single exit point. So which means that you can actually break up this long sequence of code into separate modules. Okay, so that's a advantage. Okay, and then you can easily clearly specify the code. Of course, you maintain the code. That is the advantage in the structured programming, because you can find the error and of course you can redesign the section of the code. So next one, you'll go with object oriented programming. Okay, so like you're going to remove some of the errors encountered in the procedural approach or maybe modular approach. So you can say that object oriented approach is overcoming the disadvantages of the modular and procedural approach. Okay, so object oriented programming, you are going to define, okay, the data as a critical element in the program development, and it does not allow to move freely across the system. Okay, so it's going to bind the data much more closely to a function. Okay, and you are going to protect it from accidental modification from the outside function. So that is the protection, a layer of security that it offers. Okay, so still here object oriented programming, you allow like decomposition of problem. Okay, just like the approaches. Okay, so that you can call it as the objects. So decomposition, you can call it as objects, and here you are going to build this data and function around these objects. So the organization of data and function in the object oriented program, that's how what is shown over here. So here the data of the object can be accessed only by the function associated by the object. Okay, so the function of one object can access the function of another object. Okay, so here you'll have object A, object B. So here you'll have data that is corresponding to a function. Here you have data corresponding to a function. Okay, that is communication. Again, it is communicating with data with a function, maybe like object C. Okay, so that's how the communication goes on. So the emphasis is on the data rather than the procedure. But in the procedural approach, emphasis is on the procedure, not the data. But here, emphasis is on the data rather than the procedure. And of course, programs are divided into sub parts, what you call to be objects. Okay, so data structures are designed such that they characterize these objects. And here the functions that operate on the data of objects are actually ties together in the data structure, and data is hidden, which means that it cannot be modified by an external function. And of course, objects can communicate, as we saw, data function, data function, data function. Everything is being communicated. Okay, so new data and functions can be easily added whenever and wherever necessary, and it is going to follow the bottom up approach in the program result. Then you have pseudocode. Okay, so that's fundamental to the actually the process of stepwise refinement. So that's actually a low design tool or maybe notation where you can flexibly write algorithms we don't understand. So pseudocode is nothing but a imaginary code. Okay, so pseudocode in English, of course, it's a structured English. Okay, so programming language like control structures, like we will have sequence like one after the other, selection like if statement, iteration you'll have for loop or maybe while loop. Okay, so here you define like natural language descriptions of functions or maybe data, and you'll have like programming style indentation as well for maybe grouping and in order to easily understand and maybe read the program. So this is an example, void primary election. Read all the candidates. So read means that's nothing but the states which are conducting the primaries. Okay. For each such state, you try to read the votes cast in each this state. Okay. Then assign the delegates to the candidates. Right. And again, for each of the candidate, try to print the report for each candidate. Okay. So you print the report. What are the candidate details? What was that all details like photo, ID card, all these details, date of birth, everything you are storing. Again, what they have cast the vote for their favorite leader. So that also is being read. So this is the steps to effective stepwise refinement. Okay, like you start with the initial problem statement, then you break it into several steps. Okay, take each step and again you break it into detailed steps. For example, there is an election. Okay, who are the people who are standing in the election? Again, in that constituency, how many people are there in the constituency? What are the details? So this is what they say. Okay, so keep repeating the process of each step until you get a breakdown that is not actually further subdivided. Okay, and you translate this pseudocode into real code. Okay, so the problem statement, you determine the class average for a set of test grades that is input by the user. So the number of test grades is not known in advance. Okay, so which means that we have to write a sentinel value to indicate he or she is finished typing in the grades. Okay, so you next what you do, you try to declare and you try to initialize the variables. So input grade, you are going to prompt the user and enter the input. Okay, and after entering the grade, you compute the class average and you try to output the result. For example, Marufik class subject 1 95, subject 2 90, subject 3 70, subject 4. Okay, you get some grade, you enter. Next what you do, you compute the total. Subject 1, subject 2, subject 3, subject 4, subject 5, everything you total, then divide by 5, then you output the result. Okay, right? So this is how what you go, you add the grades, you count the grades, divide the sum by the count, and this is what you do. Okay, so still it's a problem. Okay, because we do all input before doing the sum and the count, so that will require much more enough variables. So variables has to be designed. Okay, right? So we revised our breakdown of steps. So this is what we are going to do. Okay, so this is a revised breakdown of steps. You are going to declare and initialize the variables that is actually needed to store the result, that is needed to compute the result. Then input grades you are going to count and add them as they are input. So when you are entering means, for example, you say 75, again you say 65, then I should be adding. Okay, 75 plus 65, what is that? Okay, and you compute the class average. Okay, so next what you do, like you break the steps into again furthermore smaller steps. Okay, so we break down these three steps. Like input step, again you are going to break down. Okay, so loop until the user enters the sentinel value like -1. Okay, like -1 means it will exit. Okay, so from user to enter a grade. Okay, -1 to quit. Okay, so allow user to type in the grade. So when you type means it will be actually storing it in one variable. Okay, so add the grade into that variable for storing the sum and add 1 to the counter. Okay, for example, there are 5 subjects. 1 enter, next one 2 enter, 3 enter, 4 enter, 5 enter. With 5 it will stop. Okay, so finally you are going to end the loop. Okay, So we would specifically write this as a while loop, okay, or maybe as a do while loop. Okay, so one more refining step again you can do for, okay, so that's how you try to formulate the pseudocode. Okay, so for example, do prompt user to enter a grade, okay, give them the needed info, or otherwise -1 to quit. Okay, allow user to type in a grade that will be storing in a variable, add the grade into a variable, again the grade you are going to add it to the variable for storing the sum. So 65, 75, 85, everything it will be storing, and add one to the counter, so that will be tracking how many grades are there. 5 grades are there, 6 grades are there, that will be tracking. While the user has not entered the sentinel value, then -1 you can enter to quit finally. So that is how you are going to add and maybe count the steps. Okay, so if the user entry is actually great and not means it's a sentinel value. Okay, so that's how it will go with the while loop and do while loop. Okay, so prompt user, allow user, okay, if the entered values are grade, okay, not the sentinel value, add the grade into a variable used for storing the sum, add one to the counter while the user has not entered the sentinel value, and you will go with declaring and initializing variables. Okay, so this is what you are going to do for initialize the variables. They have a grade variable that is going to store the user entry, some variable that's 0, counter that's 0, and compute the answer, try to print it. Okay, divide the sum by the counter, again store the result and try to print the result. So this is the refinement technique that you will go for, okay, in order to come out with a solution to a problem. Okay, so putting it all together, initialize the variables, grade variable, user entry, some variables initialize to 0, counter initialize to 0, then grade entry you'll go with do prompt user to enter the grade, okay, which means that you're going to enter the needed info, or maybe -1 to quit. Okay, allow user to type in the grade that will be storing in one particular variable. Okay, and if the entered value may be grade not -1, add the grade into a variable that will be storing it a variable, okay, for storing the sum, and add one to the counter. For example, like 5 grades, it will stop with 5. Okay, so track how many grades while the user has not entered the sentinel value, then -1, that it will be finishing. Okay, so finally it will be computing the average. That's how you'll divide the sum by the total counter and you'll be printing the answer. Okay, so this is the stepwise refinement techniques. Right. So this is the independent work for you in the HEMIS: sorting, problem of sorting, common sorting strategies, and hash tables. So you are going to write a short introduction, then some description, the images, okay, like diagram, the flow diagram, code, definitely C program or maybe C++ program, then output snapshot, and finally result conclusion. Okay, so this is what you are going to do for all the 5 assignments.